Have you ever wondered, in the infinite vastness of the universe, what could be so powerful that it can swallow stars and even light itself? The answer to that question lies in one of the most intriguing phenomena of the cosmos: black holes. These are not objects in the traditional sense, but rather regions in space where gravity has become an insatiable beast, swallowing everything that dares to come too close. Imagine a force so strong that not even the fastest thing in the universe, light itself, can escape its irresistible pull. That's the power of a black hole. It's like an abyss in the fabric of space that gobbles up everything in its path, leaving nothing behind. A cosmic monster shrouded in layers of mystery waiting to be unveiled. But how do these fascinating and mysterious cosmic entities come into existence? Let's delve deeper. Black holes are not born out of nothing. They have a fascinating origin story. Imagine a star, a massive one, much larger than our sun. This star, like all stars, is a furnace of nuclear reactions, fusing hydrogen atoms into helium at its core, releasing an enormous amount of energy. This energy, in the form of light and heat, pushes outward, balancing the force of gravity that pulls everything inward. This delicate balance is what keeps a star stable throughout its life. However, as the star ages and exhausts its nuclear fuel, it can no longer maintain this balance. The core begins to collapse under its own gravity, and the star is now on the path to an explosive end. This is the first step in the birth of a black hole, the death of a star. As the core collapses, it triggers a supernova, a colossal explosion that can outshine an entire galaxy. This explosion is so powerful that it ejects a part of the star into space. But not all of the star is thrown away. The core, or what's left of it, doesn't escape the supernova. This remaining core, now devoid of any outward pressure, succumbs to its own gravity. It collapses further and further, shrinking to a point where it occupies almost no space. It becomes so dense that not even light can escape its gravitational pull. And voila, a black hole is born. But this is no ordinary object. This point, known as a singularity, defies our understanding of space and time. It's a place where the laws of physics as we know them break down. It's a place of infinite density and zero volume. It's the heart of a black hole, an object so mysterious that it continues to puzzle scientists even today. So, a black hole is born from the remnants of a star, but what happens inside this space phenomenon? Black holes, despite their name, are anything but empty spaces. They are fascinating celestial bodies that challenge our understanding of the universe. Let's delve into the structure of a black hole to better grasp its complexity. At the heart of a black hole, we find the singularity. The term singularity might sound exotic, but it essentially describes a point of infinite density. This is where the mass of a black hole is concentrated. The laws of physics as we know them cease to apply at this point. It's as if the universe's rulebook gets thrown out the window. Matter crushed into the singularity becomes an infinite speck of space-time curvature, a concept that even the greatest minds find perplexing. Surrounding this singularity is a region known as the event horizon. Think of it as the point of no return. Once anything crosses this boundary, be it light or a spaceship, there's no coming back. The gravitational pull of the black hole is so strong that nothing can escape it. Not even light, the fastest thing in the universe, can outrace the pull of a black hole once it ventures past the event horizon. But there's more to the event horizon than just a boundary line. It's also the outer shell of the black hole, the part that we can observe. When we talk about the size of a black hole, we're actually referring to the diameter of the event horizon. It's a black sphere that reflects no light, making black holes invisible in the traditional sense. Yet, they are detectable through the effects they have on nearby matter. Now, between the singularity and the event horizon, there's a region called the ergosphere. Here, space-time is dragged along by the rotation of the black hole itself, a phenomenon known as frame dragging. Anything within the ergosphere is swept along this current of space-time. This all seems very abstract and hard to comprehend, doesn't it? But don't worry, The next part of our journey will make things clearer. We'll take a hypothetical journey into a black hole to examine these strange phenomena more closely. Stay with us. So what would happen if you fell into a black hole? Would you survive the journey? Let's imagine for a moment that you're on a galactic voyage and you unwittingly stray too close to a black hole. What happens next is a fascinating, albeit terrifying testament to the sheer power of gravity. As you approach the black hole, you'd start to feel a force pulling you towards it. This is the black hole exerting its immense gravitational pull. But it's not a uniform pull. The part of you closer to the black hole would feel a stronger pull than the part farther away. This difference in gravitational pull is so drastic that it would stretch you out, much like a piece of spaghetti. Hence, the term spaghettification. Your body would elongate into a thin, noodle-like shape. Not the most pleasant of prospects, is it? Now, let's talk about time. We've always perceived time as a constant, right? But near a black hole, that's not the case. Due to the black hole's gravity being so incredibly strong, it warps the very fabric of space and time around it. This results in what's known as time dilation. In simple terms, time dilation means that time would appear to slow down for you as you get closer to the black hole. From an external observer's perspective, it might seem as if you're frozen in time, inching closer to the event horizon, the point of no return, in slow motion. But from your perspective, time would seem to pass normally, even as you're being stretched into a galactic noodle. So, falling into a black hole would not be a pleasant journey. But these cosmic phenomena still hold many secrets that scientists are eager to uncover. This is the beauty and the terror of black holes. They're a testament to the incomprehensible power and mystery of our universe, a reminder of how much we've yet to learn about the cosmos that we're a part of. Black holes remain one of the greatest enigmas in the universe. They are fascinating celestial objects that have captivated scientists and space enthusiasts for decades. Born from the death throes of massive stars, black holes are regions in space where gravity is so strong that nothing, not even light, can escape their grasp. We've explored their formation, a dramatic process that begins with a star many times the size of our Sun. As the star exhausts its nuclear fuel, it collapses under its own gravity, leading to a supernova explosion. What's left behind is a dense core, a black hole, where the laws of physics as we know them break down. Diving into the anatomy of a black hole, we've discovered some intriguing characteristics. At the heart of a black hole is the singularity, a point of infinite density. Surrounding this is the event horizon, the point of no return. Anything that crosses this boundary is forever lost to the black hole's insatiable hunger. But what happens inside a black hole? That remains one of the biggest mysteries. Theories suggest extreme tidal forces that could spaghettify anything unfortunate enough to fall in. Yet, recent scientific progress has opened up new possibilities. Ongoing research has led to fascinating theories, such as the existence of wormholes. These are hypothetical passages through space-time that could potentially create shortcuts for long journeys across the universe. Imagine, if you will, a tunnel connecting two distant points in space, making interstellar travel a reality. However, wormholes, like many aspects of black holes, remain theoretical, a testament to the many mysteries that black holes still hold. Despite our progress, there is still so much we don't know. The universe is full of mysteries, and black holes are one of the most captivating. As we continue to explore the cosmos, who knows what other secrets we'll uncover?